Today we're going to be talking about volume of a rectangular prism. This is when we start our 3D shapes, our 3D, three-dimension. That means we take it from a rectangle and we have another rectangle and those sides are joined and it becomes a three-dimensional object. Okay, so in this case right here, this is a rectangular prism. Direct from the star chart, we're going to get our formula, which is volume equals area of the base times height. That guy right there is new for you. You're used to volume equals length times width times height. Well, we're replacing that with the area of the base. So let's go over here and define it. Our V stands for volume. Our B, capital B, remember I told you it matters in geometry. Our capital B stands for area of the base. And our H stands for the height. So we have two shapes here. We have a cube and we have a rectangular prism. A cube is just a special name for a rectangular prism. It means that all sides are the same length, in this case 3/4 yard. So what we're going to do is start with our formula, and I'm going to come down here to this one first. So I'm going to look at finding the area of this shape that's shaded in, which I redrew here, flat, a two-dimensional shape. So I've taken the bottom of this rectangle and flattened it out. So to find the area of this, I look at my numbers, and I have 20 and 2. Both of those are meters. And I can use my area formula that I know and have 20 times 2 equals 40 meters. 40, there we go, meters squared. So the area of the base, which I'm now going to flip to a capital B, is 40 meters squared. So when I have my formula, volume equals area of the base times height, I can substitute that in. The area of the base is 40, and my height I will get right here. There. That height is 5, and so then I multiply that, and I would have 200 meters. And because it's volume, and I already have 2 here, I added that third one in, we're going to have it cubed. So I've discovered that the volume of this rectangular prism is 200 meters cubed. So let's look at our cube up here. Cube and cubed. We're first going to solve for the area of the base. And we know that the area of the base would look like that and be 3/4 all the way around. I don't want you to be scared off from doing your fractions and your decimal multiplication. You need to be practicing that. So 3/4 times 3/4. Now you know I'm going to ask you, how do we do this? Well, I'm going to help you. All right, what we do is we're going to multiply across. So you know I like to extend my line there, and I like to put my multiplication signs there. 3 times 3 is 9, and then 4 times 4 is 16. So the area of my base, that capital B, is 9/16. So then I can do my formula. Volume equals area of the base times height, and I can get 9/16. And my height is 3/4 times 3/4. And again, it's fractions. I'm going to just extend my line and multiply across. 9 times 3 is 27. And 16 times 4 is 64. All right, and fortunately for us, that can't be simplified. So we're going to have the volume equals 27 and 64 yards cubed. All right, so we're going to do some practice problems together, and I'm going to show you a little bit more of a shortcut for this, and it'll look a little bit familiar. All right, so we're going to start with this one, and I always start with my formula. Volume equals area of the base times height. Okay, so for this, we know that that is our lowercase base times height of the base. So it would be these two numbers. So the way I can do that, instead of having to do two problems, is I can put in parentheses 2 times 2. For this is my lowercase base, and this is the height of that base. What we're looking at in terms of shape is this shape down here. Once I get done there, and then I can do times my height of my three-dimensional object, which would be 5. So on this one, order of operation tells me go ahead and solve that first. 4 times 5. And so what we're going to get is the volume of this rectangular prism is 20 meters cubed. That means that inside of this, if I were to do a layer, upon layer, and keep building it up, it would take 20 meters that are shaped as cubes to do this. So on this one, this guy right here is a cube. A lot of times you'll see that where they just have one measurement like that. When they just have one measurement for that entire shape, it tells you it's a cube. It's kind of tricky that way. Always start with your formula. Area of the volume equals area of the base times height. And so I'm going to substitute in. I have 1/4 times 1/4 parentheses times 1/4. Okay? So when we solve that out, we're going to deal with this first part. With fractions, I like to extend the line, and I get 1/16 times 1/4. If you notice, I switch between parentheses and dot, and that is okay. They're both equally acceptable. So I extend my line, and I get 1 times 1 is 1. Love that. 16 times 4 would be 64. And so it would be yards cubed, because remember this guy right here is the squared, it's the base part. When we're talking about that, it's this part right there. So our volume is equal to 1/6 yards cubed. Now in 6th grade, you're just going to deal with rectangular prisms, which a cube is one. A parallelogram, if they were to do it like this, you know, with it slanted, that would be one also. Those are all rectangular shapes. They're just special types. So this is what we're going to be dealing with today. It is the same principle as the length times width times height. It's just reformatting it. It's like learning to write cursive. You're saying the same thing, but you're using proper algebraic form at this point. So you have 3 practice problems to do. The check sheet is hanging up in the classroom, and then you can start your homework. Great job, kiddos. Have a good one.